Alright, so this presentation is over the crankshafts. We talked about postponing this till this week. We talked about last week, what? What did we talk about with that presentation last week? Pull it out. What did we do last week? We did oil and coolant last week, or did we do cylinder blocks last week?
We did lube and cooling, yeah.
We did lube and coolant last week. So we've got 2 more presentations left in the class until the end of the semester. We've got this one over crankshafts, and then we've already done the one over cylinder blocks, cooling. And so let's get started on this. Crankshaft, made from iron or steel. Crankshaft main and rod journals are machined to very close tolerances. This allows an oil film between the journal and the bearings. So, any questions over any of this part of it? Yes?
If it's steel, or is it always forged steel, or is it steel and steel alloy?
It can be either or,
Okay.
but mostly it's what?
Steel alloy.
Steel alloy, yeah. Because it's probably got more what?
Impurities?
Well, if it's steel alloy, it's got heavier or lighter tensile strength. Lighter tensile strength, right? Yeah. So let's think about that though. When you're looking at an application, I mean, if you've got an engine that's a low RPM, high torque engine, do you want a lot of tensile strength?
Yeah.
Yeah. So you want something that's made out of what?
Forged steel.
Forged steel. So when you start talking about large bore over the road truck engines, then you want what?
Forged steel.
Forged steel cranks. Yeah. Yeah, you want forged steel cranks. All right, so balance shaft. So let's think about this for a minute. What's the purpose of that balance shaft on that throw on that crank? What is the purpose of that?
It's for weight, counterbalance.
It counterbalances. It gives me counterweight, right? It gives me counterweight to balance it. Because what would make this thing, just looking at it, what would make this thing out of balance if it wasn't for those counterweights?
Well, the way the journals are offset.
Yeah, the way the journals are offset, but the journals have to be offset to what? For what reason? Why?
Fire offset.
Yeah, to give me complete and smooth motion, and for my circular motion on the thing, right? To give me complete. So, look at this. Somebody come up here and look at this. I want one person come up here and look at this. What is the purpose of these holes drilled in the bottom of the?
Take weight out of them?
Yeah, to take weight out. To take weight out to balance it out, right? Yeah, that's what they drill those holes in the bottom of those counterweights to take weight away from those counterweights, so that I got an even balance on that shaft all the way around.
Can't they put inserts in there?
What's that number?
Yeah, and they can add, if they drill too much out of this, they'll add inserts back in these holes to add weight back to this thing. And I don't have that today to show you, but before the end of this, I've got a whole video set of videos from a company that builds the machines that do balancing on crankshafts, and I'll show you guys how they actually balance crankshafts. They do it a lot like they balance weights on a tire. I mean, you spin the thing over and add weights to different points to it, and then you're looking at, your different offsets or different balances on that shaft as you spin it. So they spin it the same way a lot as they do like high-speed spinning. They spin balancing on a tire. All right,
So when they're sanding that thing down, they just generally take like 1/1000 off each one of those journals and then put undersized bearings in.
Well, we'll talk about that in just a minute. I mean, you're getting ahead of yourself. We do that a lot, though, in here, don't we? But if you're looking at too much taper or too much out of round, I mean, especially with out of round. If it's too out of round, you probably, if you're going to salvage that crank, you would have to build that up with what kind of welding there?
TIG.
Levi?
TIG.
Yeah, TIG welding. We build this thing up with TIG, and then we take it and ground it back down on a lathe. And we ground it down to that size, or probably a little less. What do you think? Would want to ground it to that exact size, or a little less? A little less, so that we could use what? So we could use what?
Stock bearings?
Yeah, use stock bearings. So we try to get it back to the same dimensions so we could go back with factory bearings, right? All right.
So what's the cost of or the ballpark of a crank? Out of that 30, 40, 54?
Oh, out of the 30, 54?
Yeah, is it cost effective to do all that TIG welding on it? Because that's a high dollar.
Well, that's just it. When you look at something that's got, if it's a diesel engine, it's a low RPM engine, high torque, low RPM, especially like that engine you're working on. That's not a truck engine, or not really a tractor engine per se that you're working on out here, even though they use those in tractors. If you looked and see us, what is that engine rated at? I mean, looking at the
Industrial.
assist, what is it under?
Industrial.
Generators.
Yeah, industrial, right? It's an industrial engine. Industrial engines are made to run at low RPMs with heavy load, right? I mean, if you're dragging that gen set behind this, and when you're, you know, you've got maximum output on that generator, and you've got that, you know, you're dragging it with that diesel engine, you're gonna have a lot of what? A lot of torque on that crankshaft, right? So, I don't know, would you wanna repair? Probably not. You probably wanna stay away from trying to
I
repair
don't
something
think I
like that,
ever
just
would. I don't.
replace. Well, think about this is a crankshaft out of a 7.3 indirect injected Ford F-350. A 7.3, the predecessor to the Power Stroke. Right? Indirect injection mean had, you know, the fuel pump, high pressure fuel pump, and poppet nozzle injectors. It wasn't a Huey engine. 7.3 Power Stroke was a Huey engine. But this engine, if you bought another crank, and I know because we did this on this engine and we pulled this out, we did the job right here in the shop. When you buy this crank replacement, do you just get just a crankshaft or?
No.
Your
No.
crank bearings and sometimes main caps.
Yeah, you get crank, main caps most of the time, especially on something heavy like it. You crank, new main caps, new bearings, crank bearings, rod bearings. Are they always factory bearings that you go back with on these things? When you buy another crank, you
No.
put it in it.
I wouldn't think so.
No, not always. I mean, you know, it could be, and you gotta look at, is it new or is it, you know, it's not always new parts. It can be what?
Refurbished.
Yeah, refurbished parts. So you got to keep that in mind, especially with an industrial engine like that. If you're not going to repair the thing, would you want to buy a remanufactured crank to go back to this thing? No, you probably want new, right? But you got to look at cost effectiveness. You asked me cost. Cost on that crank alone out there would probably be $2,000 plus, I would imagine. Because that little engine there, I mean, it doesn't look like much. Weighs an awful lot because it's solid cast, right? But that little engine is an option in a gen set, or if you were to buy one. I mean, a lot of people use those things to, you know, do what the conversions on the off-road Jeeps and stuff. It's real popular, like that 4BT4 Cummins engines is for those off-road diesel
Is that
conversions.
3054?
Yeah, 3054 is popular for the Jeep Cherokees. There's a conversion kit you can buy to put that 3054 in a Jeep Cherokee.
Really?
But that engine's going to cost you probably about $8,000 to $10,000. I mean, it's a pretty steep.
And that's what that's a
So you can imagine, yeah, well, a complete used engine. I mean, we're talking used engine's going to cost you 8 to 10. That engine new, I know I've already priced them. They're like I think $18,000 for an engine.
Probably the last engine you ever got to buy.
Easy back, right?
Yeah, I mean, you think you could buy a really nice car probably for what that engine costs, right? All right, so where we at here? All right.
Well, when they remanufacture that and give you the bearing set with it, they've already got that spec'd out, and they've already torqued them down and all that. So, you know, like.
But when you buy this,
Yeah, he said when they come remanufactured, they give you the main bearings and the rod bearings. They've already spec'd all that out.
oh yeah, they've already spec it. But don't be. I mean, that's just like you buy spark plugs and they're pre-gapped from the box. I mean, how many of you guys believe that?
Second.
Actually,
I'm gonna check everything
Actually.
before I put something together like that.
the
Right?
ones for my Blazer, when I pulled them out of the box and put my gauge on them, they're right at 45 thou, which is what they're supposed to be at.
So
Sometimes.
so it checked out okay.
Who'd you buy? What brand?
Oh, AC Delco. OEM.
Oh, you're talking about spark plugs.
Yeah.
I mean, yeah, and you know, spark plugs is one thing, but I mean, we're talking engine bearings. I mean, that's a job to get down to this, right?
Yeah.
And if it comes apart after I crank it and it was a fault that something was off on tolerances, I mean, if it comes apart after the fact and it was a fault on tolerances, are they going to warranty that?
No, because it was.
No,
the
because you're
engine-
going to try to say what?
It's the engine builder's fault.
Yeah, it was the builder's fault, right? I mean, yeah, it was an assembly fault, right? It wasn't a fault of the tolerances, the machining. It was an assembler's fault. So yeah, you want to make sure you check all that stuff when you put it back together. All right. All right. Crankshaft torsional dampeners. Crankshaft twists and bend under combustion forces causing harmonic vibration. Vibration can damage the crankshaft, the engine, and accessory drive. Accessories driven by the crankshaft. Two common types of torsional dampeners used are. Does anybody want to take that one?
Dynamic.
Fluid. Harmonic.
Yeah, harmonic and fluid filled, right? Fluid filled, and the harmonic one though, how's it built? I mean, there's one that's fluid filled down there.
Rubber and two
It's got a rubber insert between the two metal parts, right? Yeah, and the fluid one just has what? A fluid chamber between my inner and outer shell on my dampener. All right, cracks caused by excessive torsional vibration. So, what can cause cracks like this in a crankshaft?
Overheated.
Too much end play.
Too much in play? I'll go with that. Too much in play could cause that. But I mean, they were just talking on that one about what? Dampeners, right? And then they're showing us an example of torsional stress
Something's
across
gone
the
on
rod
with
bearing
a
journal.
fluid filled dampener and it's causing it to crack.
Yeah.
So we could have a faulty or damaged dampener that causes us to have cracks across the crank journal. And which journal is this that we're looking at on this?
It's a
It's
main.
kind of an odd
That's
picture.
not the main.
That's a rod journal,
Rod
right?
journal.
Yeah.
And think about that for a minute. Would you have, if you had a dampener failure, would you be more likely to have stress cracks across the main journals or the rod journals?
Rod journals.
Why?
Because the mains are held down securely by the caps.
Yeah, and they're centerline board, right?
Yeah.
And these are what?
Offset
Offset, right?
board.
Yeah. So if we've got a vibrational problem, we're probably gonna pick that up more on the offset, right? Okay. Also called a vibration dampener, composed of an inner hub and an outer inertia ring connected via rubber sleeve. That's only if it's what kind of dampener was that again, Jim?
Huh? Come on. Dynamic?
Dynamic. Yeah, a dynamic balancer or a dynamic dampener, right? And as the crank twists, the hub applies force to the ring. Condition of this sleeve is critical. The story I have about dampeners is I can remember several times looking at rod bearing knocks. That's what I was told with the job, that it was rod bearing knocks. I think one was on a small block and a mid-90s Chevy pickup, and several times I've seen that on the 3800 series Buick engines. The dampener comes apart completely, so you got no rubber between the inner and outer shell and the harmonic balancer. So do you think that could make a knock that sounds similar to a rod bearing knock? Yeah. We actually bought one, and my dad did, when we were running his car lot, I guess about maybe 15 years ago, before the old guy bought the farm. And we went to the auction and bought it because it had a rod knocking in it, all right? I mean, we bought it thinking that the engine was coming out of this thing, and we bought it for $200. And the car, at the time, the blue book value on the car, I think, was like $2,800, and we bought it for $200. And guess what the problem was? It wasn't a rod knocking, it was a balancer coming apart on it. So we bought a $120 balancer and put on it, and we had a car that we spent $320 on that the blue book value was $2,800. So yeah, that was a good deal, right? Alright. So outer weight, inner shell, and this piece right in here is the what? Rubber. That's the actual rubber, right? That's the actual rubber. Alright. Fluid dampeners commonly installed by the aftermarket fluid filled dampener have a hub surrounded by the inner inertia ring. The ring is filled with a high viscosity fluid. The outer ring moves against the hub as it absorbs vibration and movement. This movement results in heat. So, how does this thing, high viscosity fluid, so what do you think? Does this thing work similar to something else that we've seen? Yeah, the viscous fan clutch, right? It works similar to that viscous fan clutch. That fluid turns, or it thickens as the thing gets what? As it gets warmer, right? If it gets warmer. It thickens as it gets warmer, right? Instead of thinning like normal oil does, it thickens as it gets warmer. Alright, let's see. Check the crankshaft inspection, check vibration dampener and flywheel mounting surface for fretting or erosion. Look for indications of damage from previous engine failure. Check journals for signs of overheating. What if you had an overheated journal? If one of these had been overheated, what would you see with the metal?
Heat checking.
Yeah, discoloration.
Discoloration, it would be blue, right? Yeah, it would be blue. Is that always a sign that I have lack of lubrication? Can that be from something else?
Yeah.
Too tight.
Just heat, period.
It can be from just heat, period. So I can have a failed cooling system
Yep.
that causes me to have ballooning on the crankshaft, right?
Yeah.
But is it going to be centralized if it's from overheating of the engine?
No.
No, it's going to be more
All the way through.
generalized, right? It's going to be more.
Dispersed,
Yeah, it's going to be more generalized to the bearing journals. All right, so check journals for signs of over. Check sealing surfaces for scoring or wear, and check for surface cracks. Sealing surfaces for scoring or wear. I don't know if you guys can see this, but on the very end of the crank, that main seal and the timing cover on this V engine would probably ride where? On this shaft, right? And if you look real close, a lot of times there'll be a groove wore down in through the crank shaft right here, where that seal rides on that end of the shaft right there. There'll be a seal, a place where that rubber's ate a hole or a groove completely into that crankshaft. So what would happen if I just throw a new seal on this thing?
It's gonna leak like crazy.
Yeah, it's going to leak like crazy. It's not going to fix the problem because the seal's not making contact with what? Yeah, it's not making contact with the shaft because there's a groove eating that. Is there any way to fix that?
Yeah,
Yeah.
there's a little sleeve.
They make a sleeve kit that you can buy to slide up. Do they do that for every engine now?
No.
Yeah, yeah. They pretty much sell those seal kits all the way around now. Yeah. Seal Power, they sell those insert sleeves to go around there to fix that front main seal leak. How about on the back? What about on the? Could you have the same problem on the rear main on this thing?
Sure.
Yeah, I mean, but if you look, I mean, it's kind of captured inside of what? And that mounting flange, the seal would be captured inside that mounting flange for the flywheel back here, right?
Yeah.
So could you slide a sleeve up over that to fix it? How would you have to fix this one, Levi? If you had a groove ate in this from that one piece of remain back here, I mean, how would you fix that?
Supposing that you're asking me specifically, I'd say TIG welding.
There you go. Well, you're my welder, man. If I need anything weld from now, I'm coming for you. I'm coming to ask you.
Bring it on.
All right, so let's pause it right here for just a second.